When we think about auroras and watching one, we automatically think about Europe. We automatically think about the Scandinavian countries or a more extreme option, Antarctica. But have you thought that it can be seen in India as well? Yes, this is the possibility today. Scientists are looking at a possibility that you might be able to see auroras, the lights in northern India itself. The question is how, what it indicates, and is this a cause of worry? Hello everyone, welcome to Vajram and Ravi's Flash News. My name is Shubhangi Singh, and in today's session we are going to talk about the auroras which are expected to be seen in northern India today. What makes them happen, what went wrong that they are being seen in India, and most importantly, what are the things that should be kept in mind. So let us begin with understanding that what exactly is expected today and what is happening. So basically what has happened is a powerful CME, that is coronal mass ejection from the sun, is coming out and it is going to impact Earth. Now based on this, it has been understood that this is nothing but a geomagnetic storm which will be created, and this is of a category G3, which is understood to be a strong one. So the categories are laid out from G1 to G5 and this is a G3 level. And this storm might be the reason that the auroras, which are usually seen in the polar latitudes, that means you will see it 90° north and in and around that, and 90° south in and around that. This is a possibility it might be seen at lower latitudes. That is why it is being expected to seen in India. Now this event, why is this happening as of now, is because of the fact that as of now we are in the peak phase of solar cycle 25. Now while telling you what exactly has happened, a lot of concepts and terms have been used. So we will be moving to break them down and understand if this is a usual situation or not. Starting with understanding that what exactly I mean when I say solar cycle 25. So when we are talking about solar cycles, it is nothing but that needs to be understood that sun is undergoing change in magnetic activity. Now this activity, this whole cycle is of 11 years. Now this is an approximation, and in this 11 years there are also two phases. One is solar minimum, where you see fewer sunspots, solar activity is limited, and there are also limited solar flares and coronal mass ejections which are coming. But when we are talking about the second phase, that is solar maximum, this is exactly the opposite of this, where we see numerous sunspots, more solar flare, and also increased coronal mass ejection. So as of now, that sun is going through such a cycle, which is the 25th cycle. 11-year cycles, 25 times have been completed. This is the solar cycle 25. And the increased activity is because of the fact that this is solar maximum, that means peak of this particular cycle. That is why we are not only seeing increased solar activity, we are also seeing very powerful solar storms, very powerful CMEs, and also auroras which are being created. So to simply understand, whenever there will be solar maximum, there will be more sunspots, there will be more coronal mass ejections, more geomagnetic storm, and that is when we will have the maximum possibility and visibility of the auroras which are created. Now the next term that we need to break down here is CMEs. When we are talking about coronal mass ejection. Now when we are talking about coronal mass ejection, you just have to understand that this is massive eruption of maximum magnetized plasma that is on sun, and this comes from the sun's outer atmosphere, that is corona. That is why it is coronal mass. Now why does this happen? Again, solar maximum, magnetic fields become twisted, energy accumulates in one place, and this is around the sunspots. That means more sunspots, that means more energy accumulation. That is when magnetic reconnection might occur, and plasma and magnetic fields, all of them are pushed out immediately into the space. Now this is where a coronal mass ejection from sun, if it is coming towards Earth, that is when it can trigger geomagnetic storms. Now another factor right here that we need to remember regarding this, that coronal mass ejection is something that not only leads to geomagnetic storms, but it also affects the satellites, GPS, communication networks and power grids as well. So this is something that scientists do understand, do report, because these all would be as well affected. I hope we are clear with this. Now let us move to understand another factor that we have talked about so that we can easily join the dots later on. That is auroras. Many of you might clearly know it as, commonly known as the northern lights. But how these are created? So auroras, yes, they are lights, but they are what? Natural light. Now it is not just single beam of light, it is a full display. And this is created when the charged solar particles, they collide with upper earth atmosphere. Now this atmosphere has presence of multiple gases, and when this magnetized solar particles interact with it, that is when the color display is created. And this display looks something like this. And it happens in multiple colors as well. The reason we see multiple colors is because of which gas it is interacting with. For example, if oxygen, then it's green. If it's high altitude oxygen, sometimes it is seen in red color as well. Nitrogen leads to blue and purple, and mixed gases lead to pink display here. Now, you might have also heard two names around auroras, that is Aurora Borealis, that is northern lights, and then we have Aurora Australis, that is southern lights. So Aurora Borealis usually seen in the northern polar region, that is 90° north and around latitudes, and Aurora Australis seen 90° south and in and around region. Now that we have a fair clarity on the concepts, now when I am seeing that it is usually seen in the polar region, this is where you should be able to question that how come it will be seen in India, which is at a much lower latitude. Now let us answer that question. So when we are talking about auroras being rare in India, that is true, because where we are looking at the latitudes from 8° north to 37° north. And auroras usually occur near Earth's magnetic poles. Now when we are talking about Earth's magnetic poles, they are not exactly placed on the poles, but they are located comparatively closer to the poles. So how do we understand how close? So if this is the North Pole, this is the South Pole, then Earth's magnetic poles are almost 11.5 degrees apart from the given poles. Now auroras are created around the magnetic poles itself. You also have to understand here the magnetic field effect, that the Earth's magnetic field, that also channels the charged particles towards these polar regions itself. And this polar region is known as auroral oval, where auroras are most likely, most frequently and most visibly seen. And India obviously lies outside it. So that is why it is rare for an aurora or expected, and that is why we have never mostly heard that auroras are being sighted in India. Now, when can India see auroras? Today, because we are expecting a geomagnetic storm of the category G3. And this is only when India can see, when there is a geomagnetic storm which is between G3 to G5. This is when there is a possibility that the auroral oval that we are talking about, that expands. And today it is expected to be seen in Ladakh, Arunachal Pradesh, high Himalayan regions basically. Why? Because these are the regions which have clearer sky, high altitude and low light pollution. So if the cloud cover allows, there is no existence of them, then probably these are the regions today that we might be able to see auroras. The possibility here is that it might be faint and limited, but yes, today happens to be one of the days where auroras might be sighted in India. So yes, auroras can be understood as a consequence of coronal mass ejection and geomagnetic storms of the given strength, but at the same time they also lead to multiple other consequences which we also need to understand here, such as such as a huge impact on communication where there is radio signal disruption. HF communication blacks out. HF communication basically refers to the high frequency communication. Navigation, GPS satellites, they report inaccuracy. Avian navigation issues are seen because of the signal and the mismatch. Now why does this happen? It is again because when we are talking about the solar particles, they are charged and they disrupt the upper atmosphere in the presence of any high frequency signals and everything around. Apart from that, we also see multiple disruptions to satellites and power infrastructure, which increases the orbital drag of the satellites, power infrastructure. There is a huge risk to transformers and grids. So yes, we might be able to see some pretty lights, which shows that how nature works in peculiar ways, but there also lies huge danger to the human infrastructure that is present. Now that was all from my side. I'll be leaving you here with the prelims practice question. Let me know the answer to this in the comment section. I'll be waiting for your answers. I'm going to show you the whole question. Otherwise all of you complain that we are not able to see the whole question. I hope you have seen it. Let me know the answer to this. That was all. Thank you so much.